We work on building the next generation of detectors that we need for the high luminosity Large Hadron Collider to understand the origins and workings of the universe. So the project that we're undertaking is centered around the ATLAS experiment, which is a very large particle detector experiment in Switzerland, Geneva. And it is probably best known for the discovery of the Higgs boson.
The Large Hadron Collider will be upgraded to a much higher collision rate, so we're going to throw 10 times the amount of particles together compared to before. And when you throw 10 times as many particles together, a lot more particles are coming out, and the current detector that is in there won't be able to handle it. So not only do we have to replace it, we will have to replace it with something much better and much faster and much more efficient. And this is the inner tracker that we're building now. It's a huge project all over the world that involves hundreds of institutes and universities.
It's the biggest science experiment in the world. So to have the opportunity to be involved at all is fantastic. And I feel every day at work, every time I find something interesting, I feel like I'm contributing to a bigger thing.
So the first petals that are being built that might be installed in the detector have actually been assembled at Fraser University. For us, it's a huge deal. We've been waiting for this for a very long time. So being able to then also build the first ones for production was quite a huge achievement for us.
SFU has a long history with the ATLAS experiment. We're hosting the Canadian Tier 1 Computing Center, which is a large contribution. And with this detector component, we are sort of contributing also to the data accumulation part within the detector, which then, of course, gets reconstructed in the computing center that we have on site. The ATLAS experiment and the Large Hadron Collider is the energy frontier. That's the only place where you can study the universe fundamental workings and discover new particles and new phenomena at the highest energies that are relevant for the evolution of the entire universe. So without the LHC, we have no direct access to any of those phenomena, and that is what drives us and keeps us up at night and try to think what is possible.